Alright, so in the last video we got to this point. We found our new pivot column and our new pivot row, so we just need to pivot again. So again, we're just going to copy the tableau down. Again, don't use colors. I'm just using this to help illustrate what's going on, but you really don't want to use colors because once you copy and paste and move things around, things will change. So again, I'm just going to copy and then I'm going to again paste that. Make sure you're only pasting the values. I got this box, it's in the way, I'm going to move it. So again, don't worry about the colors, that's not really the point, but our pivot location, as we saw, I didn't copy the row part, but our row was this row here, so let me put that in. Just copied this down, and now I want to manipulate this. Our pivot location is the cell with 3.4 in it. So what that means is once we perform this pivot, we're going to swap y for S2. So y will become a variable that has a non-zero value, and S2 will become a variable with a 0 value. So I'm going to go ahead and change that now before we do this. And then again, because we choose columns from leftmost negative, we never really have to deal with things to the left. They're already going to be in the form they're going to be in because of all the zeros. So all we have to do is to take this, we're going to say it's equal to itself from the previous, and then divide by that number 3.4. So we're going to divide the entire row by 3.4. Again, dividing the 0 to the left of that will still be 0. That gives us that row. Now again, we just need to use the 1 to eliminate the 1.8, eliminate the 0.2, and eliminate the negative 9. We have to do that across the entire row. So the 1.8 is going to be, I'm just going to say it's equal to that 1.8 minus that same number times my 1. That'll give me a 0. I got to keep in mind that I want to do this across the row, so the second number is constant every time we subtract. So I need to put that $sign in there. So that when I drag this across, the first number in this formula is going to change according to the column. This last number will also change, but this multiple that we're using won't. So then that column is done. Now we do the same thing for 0.2. I'm just going to say it's equal to 0.2 minus itself times the 1 that we have in our pivot location. I have to do the same thing again. Put the $sign. And then drag that across. Again, because of the zeros in this X column here, we don't have to actually do that, drag that to the left. You could, and it'd still give you the same number 1. So that's kind of the advantage of doing this like left to right. So we just have one more row. So I'm just going to eliminate this negative 9. So I'm going to say it's equal to itself minus itself times R1 for our pivot location. Again, I got to make sure to put in the $sign. So when I drag across, it does the right calculations across the entire column. And now we see our new tableau is giving us a new solution, a new decision. And in this case, the decision is the best because there are no more negatives in this part of the tableau. What that means is any pivot we perform would only decrease our objective function value in the lower right-hand corner. It's only when you have a negative does this number grow, as you pivot. So this is an optimal solution. And the solution is, in our original variables x and y, x has to be equal to 29.4 and y is equal to 27.9. And then we get these other interpretations as well. S2 and S3, those have columns which are not pivoted. They have a bunch of non-zero numbers in them. So those are basically 0, which is telling us that in the original problem, the second constraint, we've used up all those available resources to make this number of x and y units of whatever we're making or whatever we're deciding to do. But S1 is part of what are called the basic variables. It's in our left column here, variables, so it has a non-zero value. Its value is 64. What that's telling us is that in that first constraint, whatever number we started with, there are now 64 units, about 64, 65 units remaining. If we go back to the original problem, see what that means. Our original tableau was this. So we had x plus 2y plus s1 plus 0 plus 0, and we got 150. So whatever that resource was, there was 150 units that we could use to make these products, a certain number of x products, a certain number of y products. What our final solution is saying is that we've used up all of the 200 resources units from this constraint. We've used up all of the 175 resource units from this constraint, but we have about 65 of these 150 left over. So it's a way of keeping track of your resources, and after you make an optimal decision, what resources you have left over to then apply to some other problem.